subscribe now and press the bell icon. Never miss an update.
Hello guys, this is Netra P Chand. Welcome to my mathematics class. Let's see today's topic. Today's topic is limits of exponential and logarithmic functions. I'm back on limits after a long time, but one video on exponential and logarithmic functions I haven't made. Alright, this is the second video on limits of exponential and logarithmic functions. Today I'll tell you how to find out the limits of the exponential and logarithmic functions. These are very easy, short questions, but are very important, and it provides you the strong foundation in order to find out the limits of exponential and logarithmic functions. So I have written here some standard results. These are the results from limits of exponential and logarithmic functions. Using these three standard results, we are going to evaluate the limits of these functions. Okay, so first standard results, limit of log of 1 plus x whole upon x as x tends to 0 is equal to 1. Limit of e raised to power x minus 1 whole over x as x tends to 0 is equal to 1, and limit of e raised to power x minus 1 whole upon x as x tends to 0 is equal to log a. Okay, so before applying these results, you must be unsure about this thing. X here, like okay, here if okay debit tends to 0, here okay reta tends to 0. If here log of 1 plus reta, then reta and reta tends to 0. Like this way here Mary, suppose e raised to power Mary minus 1 over Mary as Mary tends to 0. Like e raised to power x and x tends to 0, right? X same, and then this tends to 0, and then only we can write a log a, and the limit of this is equal to 1, limit of this is equal to 1, limit of this is equal to log a. Already in one video I have proved all these standard results. Okay, so let's start questions. Questions are very easy. We can finish, okay, as soon as possible. It will not take so long time. So many questions I have written on the board, but questions are very simple and short questions, right? So let's start. So first question here, first question, limit as x tends to 0 of e raised to power 3x minus 1 over x into 5 raised to power x. We need to do, okay, arrangement. If you see, okay, you are going to find out from 0 upon 0, alright, 0 upon 0. Now this means, okay, we have to do some arrangement. X tends to 0, we can write down like this way because we have to use, okay, this exponential. This is the, okay, in first I have taken exponential series. In exponential series we need to use either this one or this one according to the function, and in logarithmic series we have to use the first result. Alright, so okay, let's try to do some arrangements according to this standard result. 3 raised to power x minus 1, here x, okay, here write down here, okay, if x we need x, okay, right? So if here 3x we need here also 3x, and times 3 into times 1 upon 5 raised to power x, okay. Alright, so no problem here. Now we can write down 3 is constant, outside we can write down limit of constant is constant, as okay 3x tends to 0, we can make for this e raised to power 3x minus 1 as 3x times limit, as we know, okay, x tends to 0, kx tends to 0, k is a real number except not equal to 0, okay. So alright, k is any real number times, okay, kx tends to 0 always, okay, there is no doubt, okay, if k belongs to a set of real numbers, k is not equal to 0, any non-zero real number. If you multiply x, you are going to get, okay, tends to 0, x tends to 0, kx also tends to 0, k belongs to r, k is not equal to 0, okay. So we can write down. So for this we don't need okay kx, and only just x tends to 0, 1 upon 5 raised to power x. Okay, so this is in standard result. This is in not in indeterminate form. We can apply. And 3 times this is 1 times 1 upon, as x tends to 0, 5x, 5 raised to power x tends to 5 raised to power 0 is equal to 3 times 1 times 1. As we know, 5 raised to power 0 is equal to 1. So is equal to 3. 3 is the limit of this function, not value of function, limit of this function. As x tends to 0, okay, this tends to 3. Okay. So alright, so easy question, right? 2 marks question. So very important question. How to solve? I think you got it this, right? I'm pretty sure and supremely confident you are gonna get each and everything after watching this video. Okay, so now I'm going to evaluate the second question. Question number second. 1 second. 1 second. So easy question. Limit as x tends to 0, a raised to power x minus b raised to power x over x. So here we have to use this result. Alright, so let's try to do some arrangement in order to get this standard result. Limit as x tends to 0, a raised to power x. Okay, we need a minus 1. So minus 1 minus b raised to power x plus 1. Minus 1 here. Minus 1 plus 1. They are okay same, but having opposite side, they will balance each other and they will cancel each other over x, right? So easy step, okay, so easy equation, that simple equation. A raised to power x minus 1 minus common b raised to power x minus 1 upon x. So simple. So simple is equal to, now almost we are going to get, right? Now we can write down a raised to power x minus 1 x here minus b raised to power x minus 1 over x. Okay, so limit, so we can write down separately a raised to power x minus 1 over x minus limit as x tends to 0 b raised to power x minus 1 over x. Alright, so easy is equal to, here we are going to get a log. Okay, you are going to get here log a. As we know, this one log a to the base e is common, is understood thing. Okay, what is the base here? E to the base e. If we don't write, this means okay, natural log we are writing. So log of a minus log b, we have still this one is in formula. If we have a log of a minus log b, we can write down log of a upon b, we can write down. Alright, so this is the limit of this function, right? Okay, now clear. Log of a plus log of b, log of a into b, log of a minus log b means log of a upon b, right? So clear, no problem here. Now you understood how to solve, right? Now I'm going, this okay, easy. Just you have to arrangement, you can do this question yourself. This question is exactly like first, you can do also this question. Alright, so I think okay, you can do. Alright, so 5 number I'm going to tell you. So 1 5, although you can, okay. Question number 5, a limit as x tends to 0 e raised to power x minus e raised to power bx over x. Okay, so we'll try to get this standard result. Is equal to limit x tends to 0 e raised to power x minus 1 minus b raised to power x plus 1. 1 minus 1 will cancel out. Okay, they will cancel each other. So no problem. Is equal to limit as x tends to 0 e raised to power ax minus 1 and minus common e raised to power bx minus 1 whole upon x is equal to, now we'll write down separately, x tends to 0 e raised to power x minus 1 over x, okay, minus limit as x tends to 0 e raised to power bx minus 1 over x. Okay, this upon this minus this upon this. Now you understood, separately we have written, but here ax, here is x only, we need to make ax, right? Then only we can write down same. limit ax tends to 0 e raised to power x minus 1 over ax times a. Alright, and is equal to minus limit of bx tends to 0 e raised to power bx minus 1 over bx. It's bx it times b. Alright, times b is equal to now here 1 times a we can write on, so a into limit ax tends to 0 e raised to, directly also you may write down, it doesn't matter, but I have written properly each and every step here, and minus b constant outside you can write down as limit of bx tends to 0 e raised to power bx minus 1 over bx. Alright, so now so very easy, is equal to a times 1 minus b times 1 is equal to a minus b. So simple, so easy, okay, not so difficult. Just we have to do some arrangement. After getting the arrangement, almost your question is done, right? Any problem? I don't so think now you have a problem. Each and every step I have done here clearly. Okay, let's move into the next question. So what's the next question? Let's see. Okay, this done now. Sixth number. Question number 6. Your question number 6 is this one. 1 6. Okay, 1 6. Limit as x tends to 0, a raised to power x plus b raised to power x minus 2 upon x. It's easy. Only just minus 2 is already there. We have to arrange limit as x tends to 0, a raised to power x minus 1 plus b raised to power x minus 1. Minus 1 in plus, sorry, minus 1 minus 2 over x. Now we can write on separately x tends to 0, a raised to power x minus 1 over x plus b raised to power x minus 1 upon x. Now write down limit xx to 0, e raised to power x minus 1 over x minus limit x tends to 0, b raised to power x minus 1 over x. As x tends to 0, okay. Limit of this when x tends to 0 is equal to log a. I'm using here this one log a, this is your log b. Okay, log of a minus log b, we can write on log of a upon b. This is the property of logarithmic, okay, logarithmic properties. So using the logarithmic property, I have written here log of a minus log of b is equal to log of a upon b. Alright, so this also understood. This is the result, this is the limit of this function. 6 10, now 7. So let's see the question number 7. So 7 also easy, I think you can. Okay, let me tell you. Question number 7, 1 7. A limit as x tends to 0, e raised to power px minus 1 will upon e raised to power qx minus 1 is equal to limit as x tends to 0. So just you can do just arrangement. Okay, here px times your, we need qx, I'm writing here e raised to power qx minus 1. Or xx, they cancel each other. Q upon p, here p upon q. Now you can say this line is equal to this line, right? Because pp will cancel, qq cancel, and xx will cancel each other, right? So this upon this you gonna get here, right? And now p upon q constant, so we can write on outside limit as x tends to 0, e raised to power px minus 1 over px and times 1 over e raised to power qx minus 1 over qx. Okay, is equal to p upon q, and the limit as x tends to 0, e raised to power px minus 1 over px, and the limit times x tends to 0. Here you may write down px tends to 0. It doesn't matter if you write or if you don't write, even then it's 1, okay, right? So better if you write down e raised to power qx minus 1 over qx, okay. If x tends to 0, px also tends to 0, here qx also tends to 0. If you drop to write down, okay, if you forget to write down, even then no matter. So you are going to get the full credit. Is equal to p upon q times 1 upon 1. Limit of 1 is a 1, limit of this one is a 1, okay? Is equal to p upon q. This is the limit of this function. So easy, alright? Now I think you understood, right? No problem. Now I'm going to tell you the last one question. Now, 8th number, 1/8, a limit as x tends to 0, e raised to power x minus e raised to power minus x plus x over x, okay? We need, okay, 1 with minus 1 with this, minus 1 with this, okay? With x, no problem. Limit as x tends to 0, e raised to power x minus 1, you can, we can see minus, okay, you just make, okay, e raised to power minus x minus 1 plus x, okay. First, let's see, okay, so is it, okay, equal to this or not, okay, let's check, okay, e raised to power x minus 1 minus e raised to power x plus 1, yes, minus 1 plus 1, they will cancel each other, no problem. No problem, you can just write a limit x tends to 0, e raised to power x minus 1 over x minus e raised to power minus x minus 1 over x and plus x over x. Alright, so I don't so think now you have any problem. So this upon this, this upon this, this upon. But here negative, okay, so we need also your negative sign. So see, okay, how I arrange, okay, e raised to power x minus 1 over x plus e raised to power minus x over minus x. Any problem? No problem. So minus plus, okay, minus and plus 1. Okay, now let's write down limit as x tends to 0, e raised to power x minus 1 over x and plus limit as x tends to 0, e raised to power minus x over minus x and plus limit of 1 is 1, constant, is equal to 1 plus 1 plus 1 is equal to 3. 3 is the limit of this function. Okay, now I don't think any problem. So I hope you can do this one. E raised to power x minus 1, b raised to power x minus 1. Only just, okay, we have to use. Like this we can do, okay, limit x tends to 0, e raised to power x minus 1x into x raised to power bx minus 1. So it's easy. So you can write down, okay, limit of this and limit x tends to 0, e raised to power x minus 1 over x and times 1 upon e raised to power minus 1 over x, because they will cancel, okay, each other and no problem. So you can, alright, this is the 3 limit of, and now you can do this also, right? Hint I have done here. So you are okay. So let me tell you, okay, after this you can move here. Is equal to limit as x tends to 0, ax minus 1 over x into limit as x tends to 0, 1 over bx minus 1 over x is equal to, you are going to get, okay, your log a times 1 upon log b. So log of a upon log of b. Alright. So this one, okay, this is the result, okay. So you can't write down here log of a minus b, right? So to write down, okay, log of a minus b, log a minus log b, to write down, okay, we need, okay, log of whole a upon b, right? So this is the limit of this function, alright? This is the limit of this function. Now I will tell you the hidden number. So okay, we have done. So remaining questions you can do yourself. So I'm going to remove from here. So I'm going to express these lines also. Okay, now I have enough space. So this question, limit solution 10 number, limit as x tends to 0 to raised to power x minus 1 over 1 sine x. So I think here I'll not get, okay, I'm so writing here is equal to limit x tends to 0. It's so simple, okay, we need, okay, for this x and x over sine x, right, is equal to limit x tends to 0 to raised to power x minus over x into 1 upon 1 divided by sine x by x, right, is equal to limit as x tends to 0 to raised to power x minus 1 over x into limit as x tends to 0 1 upon sine x upon x. Okay, so this is equal to log 2, okay, to the base e is common, so this is the 1 upon 1 is equal to log t. This is your limit of this function, right? So now I think you understood how to do this question. I think you will not have any problem, right? So I'm going to express this. Now, question number 11. 111. So many questions I have taken from exponential functions. Limit as x tends to 0 e raised to power sine x minus 1 over x. So simple, we have to do some arrangement. So 0 e raised to power sine x minus 1, okay, minus sine x, you can write down over x. Okay, all right. So here is sine x, okay, this is the important thing. Limit as x tends to 0, okay, e raised to power, we can write down e raised to power sine x minus 1 over x minus here sine x over x, we can write down one thing, okay, right? But here is sine x, okay, here is x only, so we need, okay, sine x, otherwise, okay, we can't, right? So limit, we can't write down 1, right? E raised to power sine x minus 1, alright, so let's write down here sine x. So okay, sine x over x, so see, sine x will be cancelled, cancel out, and we will have only same thing, right? This is the arrangement for this, and minus sine x over x. Okay, so interesting, these questions are very easy. Now, so write down, okay, limit, or we can write down sine x tends to, as x tends to 0, sine x tends to 0 e raised to power sine x minus 1 over sine x, right? As x tends to 0, sine x tends to 0 for this, and for this, okay, limit and x tends to 0 sine x over x minus limit as x tends to 0 for this only x, right? Is equal to 1, you are going to get, this is the 1 minus 1 is equal to 1 minus 1 is equal to 0. So 0 answer, limit of this function is 0. Any problem? I don't so think you have any problem, right? Now very important question, right? Now question number 12. Question number 12. Now I'm going to expunge the last question of exponential functions. Okay, here limit as x tends to pi by 2 e raised to power cos x minus 1 over pi by 2 minus x. Listen to me here. We need as x tends to 0. Here is x tends to pi by 2. Let's change, okay. Let's make, okay, as x tends to 0, then only we can write down, right? Okay, so how can we do this one? Okay, here also if we do some little bit change, we can do, or otherwise, okay, you can do like this way, put in, so all are of, okay, 0.0 form, there is no doubt. This is also, okay, 0.0 form. I forgot to write down, okay, every question are of 0.0 form in determinant form. Putting, you can write down, okay, x is equal to pi by 2 plus h, okay, when x tends to pi by 2, then your h tends to 0. Okay, h tends to 0. So we have limit as x tends to pi by 2 e raised to power cos x minus 1 over pi by 2 minus x is equal to, we can write limit as x tends to 0 e raised to power cos x means pi by 2 plus h minus 1 over pi by 2 minus x. What is your pi by 2 minus h? Clear everybody? So listen to me. How can we just x is putting, okay? What to put, okay, here? Putting, okay, x is equal to pi by 2 h, okay? Putting, okay, variable is equal to constant plus another your choice, okay, variable, right? According to your choice you can use, okay, variable. Here I have taken h. Instead of h you may take, okay, y or other variable also you may take, right? So it becomes your limit h tends to 0 e raised to power cos pi by 2 plus h, okay, 90, so minus sin h, okay, right? So minus sin h, 90 plus theta, okay, minus sin theta minus 1 over, here you will get, okay, pi by 2 cancel h, okay, so is equal to limit h tends to 0, okay, here negative sin h minus 1 over minus sin h times, okay, minus sin h over h you can get. You can do this type of arrangement, right? Okay, 90 plus theta here, cos 90 plus theta means, okay, sin minus sin theta. Sin 90 plus theta means cos theta, right? Okay, is equal to limit h tends to 0 means sin h tends to 0. So whether you write down or not, okay, it doesn't matter. E raised to power minus sin h minus 1 over this negative sign outside, we can write down minus, here I'm writing this one, and here minus sin h, okay, into limit as h tends to 0 sin h by h, okay, is equal to minus, and this is the 1 times, okay, here negative, this negative sign I've taken from here, okay, minus 1, this is a 1, and times this also 1 is equal to minus 1. So minus 1 is the limit of negative 1. Negative 1 is the limit of this function. Okay, so I think you understood. Now you have no problem. Right. So I have taken your 1, 2, 3, 4 logarithmic limit of logarithmic functions, right? So now we will use the first standard result, right? So very simple, to first limit as x tends to 1 or log of x over x minus 1 is equal to, so here, okay, as x tends to 0 we need, okay, so you can do putting x is equal to 1 plus h, or when x tends to 1, or then your h tends to 0, alright. So this is in 0 upon 0 form, you can check, log 1 is 0. So we have, writing here, limit as x tends to 1 log of x upon x minus 1 is equal to limit x, as instead of x tends to, we can write down x tends to 0 log of x means 1 plus h over x minus 1. X minus 1 is equal to h. Okay, yeah, 1 plus h minus 1 is equal to limit as h tends to 0 log of 1 plus h over h. So you know, right, this is exactly in this form. So here you can write is equal to 1. 1 is the limit of this function, alright. So I don't so think now any problem, now understood, okay. And similarly this also we can do, alright. Now I'm going to erase. Question number second. limit as x tends to 2, x minus 2 over log of x minus 1. Putting x is equal to 2 plus h. When x tends to 2, then your h tends to 0. So we have limit as x tends to 2, x minus 2 over log of x minus 1 is equal to limit as x tends to, or instead h tends to 0, x, what is x? 2 plus h minus 2 over log of, instead of x, 2 plus h minus 1 is equal to limit as h tends to 0, cancel h over log of h plus 1. So limit as h tends to 0, we can write on 1 over log of 1 plus h over h. So this is also in standard form. Log of limit of 1 is 1. Limit of this is also 1, right? So is equal to 1. 1 is the limit of this function, right? So I think you understood. Here also same, okay. I think now you can try. So here you will do, okay, putting, just let me tell you the hint, okay. Putting x is equal to pi by 2 plus h, okay, right? And when x tends to pi by 2, and then you will get h tends to 0. So definitely you will get, okay, right, limit of this function here, okay. Here one more thing, okay, here also putting, okay. Let me remove, let me tell you the hint of this question. Here also you can do the same, okay. Putting x is equal to e plus h, okay. When x tends to e, then you can write down, okay, h tends to 0. Alright, so one more thing, okay, here, and one more thing here, one more thing, okay. Limit as x tends to e log of x minus 1 means log of e, you may write down log e, and x minus e, no problem, is equal to limit, write down x tends to 0, log of x means here e plus h minus log e, because log e is equal to 1, okay. Value log of e to the base e means 1 over x is your x e plus h minus e. So simple. Limit as h tends to 0, e here, sorry, so I'm going to tell you, this one is here, here is equal to this question, okay. Limit h tends to 0, log of e plus h by e over, here you will get only h, limit h tends to 0, you will get here log of 1 plus h by e over h. So e is constant, okay, be careful everybody. Log of 1 plus h by e, we need also here h by e times 1 by e. So e is equal to 1 upon e times this limit of h tends to this is the first result according to this one. You can write down 1 upon e. This is the limit of this function, right? Limit of this function, and this one also you can get easily. I have given you a hint, all right? So this is not your major issue. So I think you understood how to crack down the limit of exponential functions and logarithmic functions. I think, okay, you enjoyed by watching this video. If you have any problem, you have an option, you can use that option, okay. You can write down in comment box. I would like if you share this video, if you like, and if you thumbs up this video, and if you are newcomers, please subscribe. If you subscribe and if you thumbs up and if you share, that definitely boosts me to make more and more videos. Thank you very much for watching this video.